Have you ever wondered what powers the drones flying above us? It's a question that might have crossed your mind as you watch these unmanned marvels zip across the sky. The secret lies in their engines. Powerful, compact, and incredibly efficient. Today, we're going to introduce you to one such engine, a micro turbojet engine that's making waves in the industry, the INDRA RV25 240N. This innovative creation is the brainchild of Raghu Vamsi Machine Tools Private Limited, a firm based out of Hyderabad. With the support of IIT Hyderabad, they've designed and developed this engine right here on our home soil. Its purpose: primarily to power unmanned aerial vehicles, or as we commonly know them, drones, but its potential applications extend far beyond that. So buckle up, folks. Stay with us as we delve into the fascinating world of turbojet engines and the INDRA RV25 240N. So what exactly is a turbojet engine? Well, let's dive right in. A turbojet engine is a type of jet engine which generates all of its thrust by expelling a high-energy gas stream from the engine's exhaust nozzle. Unlike a turbofan or bypass engine in a turbojet engine, every bit of air that enters the intake goes through the engine core. Now, let's break down the turbojet engine into its core components. They include the inlet, the gas turbine engine, and the exhaust nozzle. The gas turbine engine itself consists of three main parts: the compressor, the combustion chamber, and the turbine. Here's how it all works together. Air is drawn into the engine through the inlet and then compressed and heated by the compressor. Fuel is then introduced into the combustion chamber where it is ignited. The burning fuel adds energy to the exhaust stream by heating and expanding the air. A portion of this energy is extracted by the turbine to keep the compressor running. The remainder of the exhaust energy is then used to generate thrust. This process is amplified by the geometry of the exhaust nozzle. As the exhaust gas moves through the nozzle, it is accelerated to high speed as it expands, providing propulsion. To further increase the thrust produced by the engine, an afterburner or reheat can be integrated into the engine design. Turbojet engines work on the principle of accelerating a relatively small mass of air to a high speed. However, it's worth noting that optimum efficiency is achieved when the speed of the accelerated air approximates that of the aircraft. This means that turbojet engines don't reach peak efficiency until speeds approach Mach 2. Hence, turbojets have relatively poor propulsive efficiency at lower airspeeds, limiting their usefulness to high-speed aircraft. As you can see, the working of a turbojet engine is a marvel of engineering. Now, let's shift our focus to the INDRA RV25 240N. This micro-turbojet engine is a product of ingenuity, born from the minds at Raghu Vamsi Machine Tools Private Limited, a firm based in Hyderabad. They didn't work on this project alone, however. They received support from the prestigious Indian Institute of Technology, Hyderabad. The INDRA RV25 240N isn't just any engine, it's a micro-turbojet engine, and it's fully indigenous. What does that mean? It means that it's designed and developed right here in India by Indian engineers. There's a sense of national pride in that, isn't there? But what is this engine for? It's primarily been developed for unmanned aerial vehicles, or UAVs, which you might know as drones. Drones are becoming increasingly crucial in various sectors, from defense to logistics to environmental monitoring. They need reliable, efficient, and compact engines to function, and that's where the INDRA RV25 240N comes in. But wait, there's more. The INDRA RV25 240N isn't just for drones. It holds promise for several other applications in the future. Think air taxis, jetpacks, auxiliary power units, range extenders, and power generation. Picture it, a world where we zip around in air taxis powered by engines developed in our own country. Sounds exciting, doesn't it? The INDRA RV25 240N is a testament to the skills and creativity of Indian engineers. It's a symbol of how far we've come in technology and innovation. It's proof that we can compete on a global stage, that we can create something that's not just for us, but for the world. So let's not just see the INDRA RV25 240N as a piece of machinery. It's more than that. It's a step towards a future where we're not just consumers of technology, but creators. It's a beacon of hope for aspiring engineers. It's an innovation that's set to revolutionize the drone industry. The INDRA RV25. 240N is not just a piece of machinery, it's an innovation that's set to revolutionize the drone industry. You might be wondering, how does the INDRA RV25 240N work? Similar to a conventional turbojet engine, the INDRA RV25 240N works by drawing in air through an inlet. This air is then compressed and heated by the engine's compressor. Following this, fuel is introduced into the combustion chamber where it is ignited. The burning fuel adds energy to the exhaust stream by heating and expanding the air. A portion of this energy is harnessed by the turbine to drive the compressor. The remaining exhaust energy is what creates thrust, a process that is enhanced by the geometry of the exhaust nozzle. As the exhaust gas passes through the nozzle, it is accelerated to a high speed as it expands. This provides the propulsion that allows unmanned aerial vehicles or drones to take flight. In the case of the INDRA RV25 240N, the turbojet engine is optimized for use in smaller aircraft, such as drones. This is achieved through careful design and engineering, which ensures that the engine is lightweight, compact, and capable of producing sufficient thrust for the aircraft's requirements. The engine's design also allows for selective increase in thrust by incorporating an afterburner or reheat into the engine design. This is especially useful in situations where additional power is needed, such as during takeoff or when carrying a heavy payload. It's important to note that the INDRA RV25 240N, like all turbojet engines, achieves optimum efficiency when the speed of the accelerated air approximates that of the aircraft. Turbojet engines do not reach peak efficiency until speeds approach Mach 2. However, given that drones and other small aircraft typically operate at lower speeds, the INDRA RV25 240N has been engineered to provide efficient performance at these velocities. The INDRA RV25 240N is a testament to the innovation and engineering prowess of its developers.